Hi, this is Mrs. Jackson. This is Chapter 3, Section 6, Part 4. It's the last video in this section, and it's really a very short video focused on vocabulary mainly. So in this video, we are going to introduce a concept called turning points. The turning points of a function, let me write that down. The turning points of a function are where that function is changing direction. So it was going down and now it's going up. It was going up and now it's going down. So changing direction. In this graph here below, we've got 3 turning points. See if you can spot them. Right here, we were going down and now it's going up. Right here, we were going up and now it's going down. And here, we were going down and now it's going up. So if we look at all of these, we've got 3 turning points altogether. There's also some other vocab that we can talk about here. In Chapter 1, we learned that this point here is the minimum, and we always use minimum and maximum as it refers to the output. So this is the minimum, and it's the absolute minimum. You don't have to put that word absolute, but if we were to write the range for this function, that would be absolutely the minimum output that we can achieve. Whereas our maximum is infinite, right? These curves on the left and the right, our end behavior is up and up. So our maximum truly is positive infinity from a range point of view. However, when we have these turning points, we talk about these other areas here as relative minimum, relative maximum. So we can talk here as a relative minimum. You might see in a textbook that might also be called a local minimum. So let me put that in quotes here, local minimum. Right here is certainly not the maximum since we're going to hit positive infinity, but we might call this a relative maximum. Or a local maximum. So these phrases, local or relative min or max, that means relative or local in this general area. So there's certainly not the minimum output. There's certainly not the maximum output in an absolute sense. But in this general area, they may be a minimum or a maximum. And at times, when we're looking at polynomial functions in real world context, we might want to describe certain mins and maxes in a certain limited domain. And so that's why we have these vocabulary phrases so that we know what area we're talking about. All right, so key concept here. The number of turning points of a polynomial function is determined by the function's degree. And the relationship there is that the number of turning points equals the degree minus 1. So if we look at this particular polynomial graph, what is the degree of the polynomial function shown? And so if we look at the number of turning points, we have, I'm going to abbreviate here, we have 3, we said, when we observe the graph. And you have the degree minus 1. So you can see that the degree here must be equal to 4. Keep in mind that that's even as we talk about end behavior. And so if we look at what is the sign of the leading coefficient, we don't have the rule. All we have is the graph to look at, and we're trying to infer things about the function or the rule. We have an even degree, and we have up on the left, up on the right, and we know that this leading coefficient, in order to get up with an even degree, that leading coefficient must be positive. Okay, so in this video, we looked at a simple polynomial graph, and we see the number of turning points. We introduced the concept that the number of turning points tells us exactly what the degree of that polynomial must be. And finally, we see the end behavior, and we can also infer what that leading coefficient is and what the degree is. So thanks for listening. I hope this video helps.